We have Bryce and Scott. They're going to be presenting One Compromise Rule Them All. It's going to be a little bit of an addition to the previous presentation on Empire. So with that, I'll leave it to Bryce and Scott.
Thanks. Hey, I'm Bryce. This is Scott. So Scott's going to show you today. Oh, we got to turn this mic on. Can you guys hear that okay now? Yes. Great. Scott's going to show you today a little bit about DCOS and Mesos and why you might want to check out these technologies for doing job orchestration across your data centers. And then I'm going to show you today why you should take just a little bit extra time to try and secure down some of the building blocks that DCOS is built upon. So I'm going to hand it over to Scott to get you a little bit up to speed.
So, quick poll. Is anybody in the room familiar with DCOS or Mesos? Are they using that in their day job for fun? We've got a couple of people. So DCOS stands for Data Center Operating System. It was born out of a need to efficiently use resources in your data center. A lot of organizations find that just running jobs on their servers, they're seeing about 60 to 65% utilization of their servers, like the hardware that they have in their data centers, meaning they have millions, tens of millions, lots of dollars worth of hardware that's just sitting in their rooms that they're paying for that's not really giving any use for them. So DCOS was born to kind of solve some of this problem. The philosophy behind DCOS is you treat all the resources, hardware in your data center as a single box. You bubble all those resources up into one place where you can then send jobs to different places to make sure that you're running your hardware as efficiently as you can. Yeah, so at the bottom of this cluster, you need something that can run it like an operating system, which is a kernel. Mesos is kind of the kernel layer of this DCOS. There are two pieces of Mesos. There's the cluster, which is a set of masters that receives offers from agents or slaves. The agents or slaves you install on hardware or VMs or cloud instances that make resource offers up to Mesos. So that's this bottom tier. On top of Mesos, you have a set of frameworks. Those frameworks do job definition. So if you have like a set of Apache servers that you want running, if you have batch jobs, if you have scheduled jobs, there's different frameworks that will handle those different types of jobs. On top of that is where you deploy your applications. Usually, these are multi-tenant clusters. They can be multi-tenant clusters, meaning you'll have jobs, different types of jobs running for different teams, probably not different companies, but more than likely different types of jobs running on here. These are usually packaged up in containers, a handful of different containerizing technologies, but typically Docker. So you write your job in Docker, you orchestrate it using a framework, and then Mesos takes those job definitions and spreads them across, finds places for them to run. A little bit more about the communications between these. The agents are running on this hardware at the bottom, or VMs or whatever. They communicate with Mesos using a configuration share called Zookeeper. Easiest way to think about Zookeeper is basically a network accessible JSON object. So key store, I store this value, I retrieve this value somewhere else. So the cluster, the slaves will say, I have hardware, I'm offering it, it'll put an entry in this key store. The Mesos will pick that up, match a job with it, put it back in, and the slave will pick it back up and start executing that job. Between the kernel and the frameworks, which is that kind of top purpley one, those are typically done either via Zookeeper again or REST APIs that are built into Mesos. Some of the common frameworks, Marathon is probably the most common one. Pretty much any deployment of Mesos that you'll see will also have Marathon living next to it. Marathon's for long-running jobs. It's also used for scaling jobs. So if I have one Docker container, I create a job definition, put that in Marathon, and then you can say, oh, I want 10 of these running or 50 of these running. You can drive it using the API, so collect other metrics from the boxes, say as performance hits 80% utilization, increase more instances in this pool. Kronos is basically like cron for DCOS. So you can give it a job definition, which can be something as simple as just a normal bash command. Give it a time frame and a frequency to execute on, and it'll just, whenever that time frame hits, ping it. So you can see a lot of the correlations between DCOS and these services and frameworks as you see in a normal operating system. Yeah. So typical use, I have my Docker container. I create a job in Marathon here. Mesos finds a host to run it on, sends the command to the agent. The agent pulls down the Docker container, runs it with whatever environment variables or arguments need to be passed into it. And yeah, that's kind of the typical use. Yeah, I'll hand it over. Oh, no. Quick demo. So this is what DCOS looks like as a UI. So it shows what your utilization is across the host. Obviously, we're not using our stuff very efficiently right now. You can see what services have been spun up in DCOS. Kronos and Marathon are frameworks, but they can also be run inside of Mesos. So here, there's a little bit of inception going on, but Kronos and Marathon services running inside of Mesos as well as communicating with Mesos. If we wanted to set up a scheduled job, we would jump into Kronos. Come on, Kronos. And you could create a job here. It's been a little sluggish. Come on, Kronos. Guess we didn't do sufficient sacrifices to our demo gods. Effectively here it'd pop up, you give it a command, you give it a time frame, and whenever that time frame hits, it will trigger the job. Via Marathon, I wonder if we're having VPN problems. No, we're good. Oh, all right. Okay.
We'll just talk about it.
Yeah. Marathon, you'd be able to see the jobs that are already defined, how many instances they're running, and you'd also be given the option to scale it up or down. So it's really well built for scaling and high availability of your application running in here. Obviously, this is a pretty small cluster, and conference Wi-Fi isn't awesome, but yeah, we'll move forward. I don't know. You can take it back over?
Okay, sounds good. Thanks, Scott. Okay, so how many of you seen Lord of the Rings? Yeah. Okay. So I know we just went over a lot of stuff, right? And for the most part, people haven't heard of these technologies before. So these technologies are being moved towards high utilization inside of companies that you guys are probably acquainted with. Like, for example, if you go to the Mesos website, you'll see a list of over 100 companies. Some of those are like Airbnb and things like that are using the cluster to automatically speed up processing and do kind of CPU intensive tasks at scale. So, all right, so now we're going to talk about initial access inside of the cluster. So this talk is more a post-exploitation talk, and we're going to show you some brand new Empire modules that are going to enable you to talk to these various building blocks or services that are inside of the DCOS cluster. So that's kind of the crutch of what we're getting to. But before we do that, we got to get initial access into the cluster, right? So how many of you have ever hacked a website before? Raise your hands. Yeah, so, you know, there you go, right? So go over here on the VPN. Okay, great. I'm going to go over here. So I have this container. It's running inside of our DCOS cluster. This is publicly accessible on the internet, so it just has a a vulnerable PHP application. So this isn't anything crazy, but if you see here, I just wrote really quickly this eval.php, and if you pass eval, and I'll show you this. So you just pass eval a parameter, and that parameter just gets evaled, right? So you get system on it. So that's really trivial. That's not anything mind-blowing, because what we're trying to do is show what happens once you get remote code execution on inside a web app inside of that clustered container. So coming over to here. So I'm going to SSH out to my box and pray to demo gods that this is going to work. All right, I'm going to drop from VPN. See if it works then. OK, we're on the box. Sweet. Is that text clear? Big enough for you guys? Or you want it bigger? Bigger. Bigger. All right, bigger it is. Got to give the people what they want. All right, is that good? Yes. OK, all right, sweet. OK, we're up on our box. We're a hacker, right? We've used this eval shell to drop down a Weebly shell on the box. A Weebly is like a C99 equivalent shell that I frequently use when I'm pen testing websites. How many of you, raise your hands, have heard of Weebly before? OK, quite a bit. Cool. So it's kind of modular, like Metasploit. You can write additional code, and it'll actually eval it using a PHP eval on the server side and kind of keep it more in memory. So if someone does on-file disk analysis, they'll just find the highly randomized Weebly loader on the remote side. So if you haven't used Weebly before for web shells, you should definitely check it out, although that's not what this talk's about. So, so I got a bunch of screen sessions running on this. So I got one set up for Weebly. Weebly, you give it the name of the Python, which is the operator side of Weebly. Then you give it the web address. So you can see here, this is our website. And this is you need a password to interact with it. So I'm going to tear this off the internet, hopefully after the demo. So you guys can't hack my box. But please don't screw up my demos in the meantime. All right, so when you drop into Weebly shell, you just get this prompt. If you execute a regular command, you can execute commands just like you were on the box. If you want to execute a Weebly-specific module, you can just do colon and then the module name. Or if you're confused, colon help will list out all the modules. So we're just going to use this to get interactive. Sweet. So we got kind of a web shell on the remote target inside this container, inside the DCOS cluster. So what we really want to do is we want to get a full interactive remote access tool running on that remote side, right? So we can pivot through the network, redirect, things like that. So how many of you, raise your hands, have you used Empire before? Any version of Empire? OK, a couple. OK, what about Meterpreter? You guys use Meterpreter? Yeah, a lot of you. OK, great. So it's just a post-exploitation RAT. Allows you to interact with the system. So there's two versions of Empire. There's the PowerShell version, which is for Windows, and then there's the Python version, which is more focused on OS X. Recently, code changes in it have enabled you to also use that on CentOS and BSD targets, backporting support for Python 6.2. So you can use. So if you run into a Nix target and you need a RAT, you can go to Empire written in Python. So we want to get Empire running on this box, right? So one catch. People, they're obsessed with making their containers as small as possible, right? So they want the least amount of dependencies in the container because they want them to be able to easily scale, and they want them not to take up as much resources. So what does that mean for us as an attacker? We don't have as many options for post-exploitation as you might on a normal Nix box, a normal Linux box. So let's say we're on this box. We really want to get Empire up and running on it. So normally if the Python would be there, we'd just be able to execute Empire and be good. But if we do which Python on the box, it doesn't return back anything because Python's not installed inside the container. So Docker, how many of you guys used Docker before? Raise your hands. Yeah, some of you. So Docker has a repo that's public. So I pulled down the top 5 containers in the Docker repo. So this is the top 5 containers that people have downloaded. Of the top 5, only 1 had Python installed on it by default. So as a person who's trying to hack into DCOS clusters, this poses a problem for me. So I built a stager, a new stager for Empire, and I'm gonna, for all the new stuff, I'm gonna push it into, do a pull request tonight for it. So if you guys check back tonight, you'll see it's there. Well, at least in the pull request until Will or whoever accepts it. So, all right, cool. So we got, oh yeah, we got actually, I gotta show you guys that, the solution. So the solution that I've come up with is, it's not the perfect solution, but it works, is I built a Empire stager that will actually build an ELF binary using PyInstaller. So it's going to generate your stager inside of Empire, then it's going to reach out to PyInstaller and compile, figure out what dependencies that needs, and then compile that all back to an ELF binary that you can just remote up. You can remotely drop that ELF binary in the target. For those of you who don't know, ELF binaries are like EXEs for Linux systems. So, all right, so here we go. Let's go over to Empire and interact. All right, have I lost anybody? Maybe, but if you guys have questions, feel free. All right, I get thumbs up, so I'm just gonna keep going. So, all right, so I'm gonna show you guys how to use Empire as part of this. I'm sure Will did a much better job, the guys before, but I'll show you my way. So you just /empire, and then you need to establish a listener first. So there's a port that we're gonna bind to on the attacker side, and this is what our Empire rat is going to beacon back to, and we're going to use to interact with the remote container. So right here, if you copy what I'm doing in this presentation in a real pen test, you're going to have a really bad OPSEC and probably get caught. So you might want to up the game a little bit. But I've just established the default, which is it's going to listen on port 8080. So when we execute the Empire rat, it's going to connect back to this server on 8080, and then we're going to be able to issue commands and all that. And I just named the name of the listener test because I'm trying to get stuff done. So then we do use stager, and then we just do PyInstaller. So this is a new thing, right? So, but the other it works exactly like the other stagers. You just do use stager, PyInstaller. It shows you all the options you need to set. The only one we really care about right now is we need to tell it which listener to call back to. We only have one listener, the test one, and that's bound to port 8080 TCP. So set listener to 8080, or to test, right? And then do info. And then the only one other thing you want to note here is it's going to build the ELF binary and chuck it in temp and call it Empire, right? Not too stealthy, but nonetheless, it's going to work, right? So. Okay, here you go. So what it does is it's going to reach out, scan through a couple Python files, figure out what dependencies you need, collab those back together into this Python file right here, and then reach out to PyInstaller and automatically use it to create the ELF binary. So the ELF binary is now made on this remote system. So if we go into /temp, we can see there's now a binary called ELF, and if we file it, we can see it is in fact an ELF 64-bit binary. If you want to do something crazy, you're like, I really like where you're going, but I want to go put some crazy code in and then have it compile it. Just for convenience, I left the source file here, and I left the spec file, which is what PyInstaller uses to compile and make the ELF. So you can do some easy customization there. Kind of use this to jumpstart. Okay, and then just because I'm just trying to demo things to you guys today, we're just going to move these binaries into target by basically doing a PHP version of wget, right? So I started up just like a kind of a ad hoc web server on this box. And you can see the ad hoc web server is running here. But just in case you don't know this trick, this is a really cool trick. If you're on Python and you need a really quick HTTP web server, you just do python tech-m for module, and then do simple HTTP server, and it'll actually establish a web server on the box. And we'll dish out any files that are in that directory. So here we're going to dish out files that are in /temp. So it's just kind of convenient. Okay, yeah. What's the question? Back? Okay. Here you go. So that's just a trick because do not like setting up Apache web servers just to pull down a file, right? So, oh, shouldn't have quit that, wrong thing. All right, we're good. All right, I just said a lot of words, so hopefully you guys are still tracking with me here. All right. I swear, once we get in the network, it's going to be like butter, okay? So just wait for it. I know it's a lot of setup for it. All right, we're back in Weavely now. So we got to wget the binary. Weavely makes this super easy. It actually just has a function. And I'm going to find it. Oh, let's make sure it's not there from a previous demo. Nope, we're good. Nothing's in /temp on the remote target. Now we're going to use this module, Weavely module, to basically wget the file using PHP. Yay, Weavely makes our life easy. So we just wait a second because it's downloading a file. The file is now there. We can even command up in Weavely, and now we can see the file is on the remote target. So we just need to make sure we chmod it, and then to make sure it's executable on the remote target. This is a Linux box. Then we're just going to kick it off using just a straight command. So this is the Weavely, the PHP shell is going to kick off Empire, the binary pulled down using Weavely from the simple Python server. Okay. All right, here we go. All right, now in an ideal scenario, if we come back around to Empire, we'll now see the glorious text that we've all been waiting for, which is initial agent from this IP is now active, right? So this means we got a new agent inside the target network. So if we type agents, we can see all the agents. There's only one here. And then we just type interact, and then the name of the agent. And then we can, one thing that is really helpful inside of Empire is the rename. So we just rename that to whatever we want. So I'm just going to rename this to like a, I don't know, web app or something. So we can remember where we are in the networks. Because we're not going to just stop at one agent, right? We're going to go through and tear this network up. So, all right. And I got to get back to the slides because we're missing out on some killer memes, right? So these are the top 5 that I analyzed. Only one had Python, and that's the registry one. The other 4 top ones did not have Python. So if we use the PyInstaller trick, we can get around that. Yeah. Pack it up, boys. We're going on a pwn trip. So this is pretty much us now. We are that hacker dude, that's Scott, master hacker. And then throwing lightning bolts, we get that little icon with the Python. That's like the little Empire logo. I don't know, maybe you guys got some of the stickers from before. So we got that running inside a container inside the DCOS cluster. So what we first got to do when we get inside a DCOS or Mesos cluster is we want to orientate ourselves by doing a little bit of recon against some of the systems that hold information about where services are available in the cluster. One of the tenets of the cluster is basically a slave can die and a new slave can come up, and the cluster will make sure like always 3 of this container are running or always 100 of this container are running, and it will realize, oh, those died, we need to spend more up. And you can also do like traffic redirection through HA proxy and all kinds of other stuff. So, all right, so I'm going to show you now how to extract information from Mesos DNS service. So Mesos DNS, it provides 2 avenues for containers or services or apps to get information out of it. It provides a traditional DNS service. I'm not really going to talk about that today. Any of your traditional DNS reconnaissance techniques will work against that. What I'm going to show you is they have a new API that they've built out that I feel like a lot of developers are going to use to try and orientate themselves inside the DCOS cluster. So I'm going to show you how to extract information out of that. And we need that information to exploit more stuff.
Can I make an interjection?
Yeah, go
as you're
right ahead.
switching over. So the DNS, both the service and the API, is pretty important to the whole ecosphere of Mesos, based on the concept that basically any service could end up popping up on any agent. So in order to figure out what resources you're talking to, you can't do that by IP. You have to be doing it by DNS record. So this isn't really something that could easily be stripped out of all of Mesos because the frameworks themselves need it to know what endpoints to talk to, both for IP and port, because either one of those could be random. Well, is random in most cases.
OK, great. Thanks, Scott. So interacting with the web app Empire agent. So I wrote this module for Empire. It's really nothing more than it allows you to do DNS lookups inside the network. I just wanted to show you something about the DCOS cluster so you kind of understand the easiest way to kind of orientate yourself once you get initial access. So there's a TLD called Mesos. So, and most of the services will have a name under that. So master.mesos, once you get inside the network, will resolve to the master. Marathon.mesos will resolve to the marathon box. Chronos.mesos will resolve to the Chronos box. And then you can also see what things are co-hosted because they're going to give you back the same IP. So if we just do, we just set master Mesos and then execute. I don't know. Then it just shows us, hey, it's on this 10 dot address inside the internal network. It's just doing a DNS lookup. So go into something a little bit more, I mean, that's really simple, right? You could do that using ping or anything on a box. I want to show you a module that I wrote that, so the next thing you really want to do is I wrote this other module. It's Mesos, DNS, API, enumerate. So when looking through the source code, I found an API function called enumerate. It is basically the equivalent of a zone transfer. So it will dump all of the data about everything in the cluster that Mesos DNS knows. So I don't think this is undocumented, but it's also not in the documentation. So, but the developers do talk about it like in GitHub issues. So I think the documentation has just not been updated yet. So, but I mean, you can have your own opinion on that. So, Mesos DNS, it listens on TCP port 8123. And we can just determine where that is because it's usually co-hosted on the master. And this will just make a web request out to it, call the HTTP API, and then we'll collect the JSON. It returns the results in a JSON format, and then Empire is just going to record those down to disk. So you can see this worked. It recorded it to disk right here. And I'm just going to show you what it looks like, because a couple modules kind of do the same thing. But oh man. But I just want you to kind of be able to visualize more what this looks like from an attacker's perspective. OK, so it just returns back this JSON blob. And the first thing it's going to tell us is the frameworks that are in the cluster. And then it's going to say, hey, inside this framework, there's tasks. And inside here, there's this proxy. And this proxy is on this slave, like this physical hardware box. That's the IP of it in the cluster. And then the most important thing that this is going to give us, though, is the IP and then the random high port. So one of the things you're going to find with DCOS and Mesos is services are coming up, scaling up and down, and every time they do on a slave, their service is not going to bind to a normal port. So even though this is probably a proxy for Apache or another web service, it's going to bind to these random high ports. So querying the DNS service and figuring out what those are is going to enable us to further exploit additional services. And what we really want out of this is we want this Chronos, because Chronos is kind of like cron tab for the DCOS data center. So if we can interact with Chronos, we can schedule malicious tasks and execute them. And so here we see that Chronos is on .160, and then the most important thing is Kronos' random high port is 61232. So you could, I guess, scan the whole cluster to figure these stuff out, but it's just easier to ask, right? So. All right, sweet. All right, so we know where Kronos is in the cluster now. So now we can do a little bit more ponage. What time we got? 35? Oh. Okay, cool.
Most people keep Mesos as their host DNS name.
So when you set up your cluster inside your data center, yeah, most people use that TLD for.
Can you repeat the question?
Oh, the question is, do most people use the Mesos domain name? Is that it? So, and the answer is yes. Like a lot of people are hard baking that into their infrastructure. Like one, it's used by a lot of the frameworks by default, and then two, you have to have some way to discover where the services are so you can interact with each other. The real problem here is that there's really no RBAC, right? So there's like, why does a web app need to be able to ask where the Kronos cluster is? It doesn't, right? But it can get everything. So, which I think they're working on, but it's kind of like a work in progress. So, okay, cool. So we can also interact with the master via its API. And then the one thing that this is going to give us is it'll give us a complete list of all the slaves that are there, all the IP addresses that are in the cluster. There could be slaves that are in the cluster that we want to get on, but are just like don't have any Docker containers on currently. So we'd kind of miss those if we just went after the DNS service. So I'm just going to kind of skip over that because it's the exact same thing. It's another module releasing and then returns back a JSON blob. Got recon for sure. Okay. All right. So we got our Empire agent, and then we got Kronos running in a container inside the cluster. We now know where that is via our reconnaissance modules. So now we're going to interact with that to get additional empires inside of it. All right, so I got really excited because I was like, great, we're not going to run inside a container anymore. We're going to use Kronos to pop out and run as root on these hosts. So we should be able to natively use Empire without having to compile to the ELF binary. That premise did not work out. So the CoreOS is kind of another stripped down OS designed for loading of containers. And the version of Python that's installed on it by default does not have URL lib2, which is a requirement right now for using Empire natively. So it's not a big deal. We just use the ELF binary again, but I was a little bit disappointed, right? So, all right, coming around to here. All right, so we can do the recon. The only thing about the recon that you really want to take note is against the Mesos master is it listens on TCP port 5050. And for the most part, people aren't going to change that because all the slaves or agents are going to have to talk back to that. OK, so here we go. This is where it starts to get a little bit funner. So I wrote this module. It's called Kronos API List Jobs. And what it's going to do is inside of Kronos, which is here, we can visualize the list of the jobs, right? So this is going to interact with the API, pull back a JSON blob that's going to have this do the thing Kronos job in there. And all this job is really doing inside of our cluster right now is it's saying, hey, execute the sleep command on the box. So this is kind of just a demo thing. But so what I like to do is I list all the jobs in the Kronos framework. Then I can add a job that looks really similar to the other jobs to blend in, and then execute that job, and then delete that job so I'm clean. Because I don't want someone to come in and find my job, right? So, my malicious job. So So we get a listing just by interacting with the Chronos.Mesos TLD. We just execute on that. And that's going to save back a list of all the jobs to this JSON blob. Just looks pretty identical to the last JSONs that I showed you, so I'm not going to open that up. But and then now let's go add a job, right? Now that we know what the jobs are, let's go add a job. So Chronos API add job, we do info. Okay, so there's a couple things we need to do here. Like one, where's Chronos in the network? We can pretty much use the TLD trick to do that. Then two, these parameters right here, we mostly just want to blend in with what we listed out. Like we probably don't want to make up an owner that doesn't exist. Somebody might get suspicious if they have logging enabled about that. And then the name of the job, or the description of the job is when you click on the job in the GUI. You can see the description's right here, so you just want to blend that in. And then the name right here, we want to blend that in too. So I just call mine scheduled job 001, description scheduled job 001. And then the main thing that we want to change here is the port, right? So Mesos is going to automatically deploy the container inside the DCOS cluster. So remember, we have to use the DNS recon to figure out what port it was. So if you guys were, I think it was 6232. Okay, great. And then by default, this is just executing the ID command. So we want to do something a little bit more malicious than that. So we go over here, and we're just going to execute this, this one-liner here, which is going to set the command to curl the Empire binary that is available via our Python simple HTTP server, set it as executable, schmod it, and then execute it on the which. And so we're not really specifying, if you notice, which slave or agent to execute this on. The framework's going to figure out what has resources and just randomly deploy it there. So I'm working on a newer version of the module right now that actually is going to let you set that parameter, because I found a way to do that. But that'll be like a week or two before I get that out. So we just set that, and then you can type info, and then you can see our malicious command is set up there. Well, could. And then we type execute. So with Chronos, it's kind of a two-step thing. We're going to add it, and then it's kind of like, it wants like a cron schedule. So we could set the cron if we know the remote target's time, or assume the remote target's time is similar to our own, so that it would execute like in 5 minutes or something like that. I don't know if you guys remember like scheduling at jobs in Windows domains and classic stuff like that. We could do that same thing here, but there's actually an API call that just says execute now. So I wrote another module for that. But hopefully this one comes back and worked. Come on, buddy. Don't do that. Go back. Did I screw something up? It's kind of hard to tell with the resolution, eh? I'll make it big again once I figure this out. Web app, you guys, 6232, web app, command, Chronos.
Try a different job name.
Oh, you think the job? Okay, let's just go check agents. Oh, no? Okay, all right.
When did you set it to run?
Oh, that's right. We didn't set it to run. Yeah. So. Yeah. That's like. So it should.
So let me jump in really quick.
Yeah, go ahead.
So in the Chronos job definitions, it's not a normal cron schedule. It's not like *1** or whatever. You specify a start time and a period. So if you say go 24T, like a 24-hour time period, but start sometime in the past, it'll fire immediately, and then it'll fire 24 hours later. So it's not a normal cron schedule, it's a start time and period, which is kind of, it's a little bit different.
Demo gods are never easy.
No.
All right. That's okay. So. Yeah, it should show up here if it was working.
Chrono
Why-
seems to be having a hard time.
All right, okay, just 1 minute. Just jump back into Weavely. Right, you still see it's executing. Interact again with the session. Kick off another one.
TMP.
Thanks. Go back around to Empire. Okay, agents, interact, use 7. All right, okay, go here, use this module.
Is the simple Python server still running?
Oh, that's a, well, that shouldn't matter for this, right? But yeah, we should check that too. So set this, set the port. Okay, and then do execute in the remote target network. Okay, there we go. Okay, all right, so hopefully it shows up now here. I don't know why that other Empire died. Okay, there we go. There's our job, AAA. You can see it's malicious. You can also see the last time it ran was never, because we haven't started it yet. If we actually set the timings correct on it, we could get it to like schedule out for 5 minutes. But it's just easier, in my opinion, to use this other API call. And hopefully I'll be able to consolidate these all into like one module in the near future. Then execute. Okay, come on, buddy. Oh, the name is wrong, because I changed it. Set name to AAA, and then execute. Okay, great. So you should see over here in a second, it's going to refresh, and then it's going to say running. So we got running now, and that's great, because hopefully it pulled back down our Empire. And we got a new Empire agent on the inside the system. So we can go to agents, and we can interact with the new one. And so cool part about Empire is you can see who you're running as over here. So you can see we're running as Apache on the first 2 ones. Then this new one we're running as root. So, and then we can just make sure we're running as root by doing a shell ID execute. And you can see it comes back with the ID command. So oh, thanks. That was a long road, but so awesome. Yeah, you want to schedule a job, and it's executed. So that's basically the diagram. We had the agent because we popped a web server. We talked to Kronos framework after doing a recon to figure out where it is, and now we got Empire running as root inside the cluster, right? You could just repeat that until you get a code execution on every single slave or agent as root inside the cluster. Yeah, or I'm working on a new technique to get you more targeted in the network. Okay, cool. I'm just going to check time. Oh, we're pretty high on time. So I'm not going to do this one, but figured out how to do the same thing, but instead of interacting with Kronos, we just interact directly with Marathon. I've never seen anyone run a Mesos cluster without Marathon. You could technically not have Kronos in there, but you pretty much need Marathon. So if you can talk to Marathon, you can do the same thing. It's the same process. You need Marathon, right?
Yeah.
Yeah, you're pretty jacked without it. So, all right, so that was that demo. I'm skipping it. Your data center is too pretentious. And that would get us a slave running as root. That would get us running an Empire running as root on another slave. All right, so, all right.
Yeah, so once you own the cluster, like you can spin up jobs, you can spin those things out, and you'll notice that at no point did we do any kind of container breakout to go from having access in this container to having agents running as root on the other agents. So once you get there, where can you go? DCOS is highly automatable, and most of the time when people are using it, they're going to be interested in tightening up their release pipeline. So a lot of times when you'll see DCOS, you also see people doing the same kind of like really high-speed releases, like automated everywhere from a push to Git to a new version of your application coming out and running in production. What that means is you'll often see these boxes in production with access back to some point where build artifacts live. That could be back to Git directly. It's almost guaranteed to be back to some kind of Docker private registry. So by looking at the job definitions that you'll see in Marathon and in Kronos, you'll see the credentials and the locations that you need to go back and pull more pieces of information out that could be useful for in your pen test. Most of the time, these applications running in the Docker containers are not going to be completely self-contained either. Like they'll need some kind of persistent storage out to a database, out to an object store, somewhere that they can maintain state. That means that these credentials that the application will need needs to get into that container somehow. That's either going to happen as part of creating the Docker container. Jenkins may bake those in and then ship it off to the Docker registry. Or it could be defined in the job definition as environment variables. There's a couple things you can do there to try and make it a little bit more difficult, but eventually the application is going to need those credentials to remote resources. So if you have control of the cluster, you have control of all the avenues of getting those credentials in. So recommendations on how to trim some of this down. Some of the components in DCOS do have authentication available. Most of the time, it's not set up by default. A lot of the frameworks only allow basic authentication. Some of the frameworks require zero authentication, and you can't set up any authentication. Otherwise, it'll break the whole framework. So wherever possible, on your frameworks, on Zookeeper, enable authentication, enable it on the UI, enable it on the API. Try and limit that down as much as you can. One attack avenue that we didn't really talk about was slave authentication. If you had visibility to Zookeeper on the Mesos master, you could spin up a malicious slave register and start receiving jobs from that master. So make sure you turn on agent and framework authentication. And yeah, hope nothing breaks. Definitely test it out first. Next is segmentation. For the demos, Bryce compromised the container and then was able to immediately hit the Mesos, like the control plane from there. Most situations, there's no need for that to happen. There are a handful of technologies you can use to shove the whole IP stack into the container. You override the Docker bridge with another way to access the network. You can use a project like Calico, which then can put down a BGP overlay, allowing the communications between the containers on different hosts. Do everything you can to segment IP access from the container to only the resources it needs. Don't open up the management plane if you don't need to. Next, update. Like this is pretty cutting edge stuff. Mesos 1.0 was released like 5 days ago and had some security features in there that we haven't really been able to do a thorough exploration of. Right now, in the versions we did an evaluation of, there's no role-based access control, meaning if you get into DCOS, you're an admin, and you can see your jobs, you can see everybody's jobs. With the new version of Mesos, there's some role-based access control in there that's supported at the Mesos layer. The frameworks still have to catch up to that in order to really make use of it. So a couple companies that are using Mesos. This is typically used by organizations that need to run products at scale. You want to do your InfoSec feud?
Yeah. Okay, cool. InfoSec feud. So I just wanted to see, like, what's the most egregious thing I could find on the internet, right? So here we go, right? So there's really no reason for any of these services to be on the internet. They should at least be protected to force you to get a foothold in the network before you can pivot to them. But I thought, let's go to a major cloud provider. Let's see how many people have port 8123 open, and let's see what I can do, like just a little bit of recon, nothing too crazy, right? So looking at Mesos DNS, how many servers do you think were accessible via the internet, via a quick scan of a cloud provider?
Thousands.
I was hoping for a lot more, but I found 54 by scanning one cloud provider. So that were open on the internet. So a little bit, and then
So we jump back one.
Yep.
So each one of those represents an entire cluster, which could be 2 machines, it could be 1,000 machines. So that's not 54 boxes, that's 54 clusters.
yeah. And then how many of them do you guys think my zone transfer trick worked against it? Yeah, I thought it was going to be 100. It was about 50%, and that's because I think it's a newer feature, so only about half of them are up to date. So that's my theory. I don't know. You can go do your own research. Yeah. Okay. All right. So you can also interact directly with the Mesos master. So I just did a quick scan of that. How many do you think were directly accessible from the internet? Okay, I'll tell you. So 41 is what I found. So these are things, if you just know how to talk the protocol, you could tell them to execute commands as root across their entire clusters. Right? So it's kind of a big deal. And then the one that I was really surprised about was Zookeeper. So I thought, okay, there's like 50 boxes for these other 2 services. We'll probably have about the same for Zookeeper. Anybody want to take a stab at how many Zookeeper servers I found on the internet? 3,000. And so why this is because Zookeeper predates DCOS and Mesos, and so a lot more services require Zookeeper. But how many of these do you think enabled authentication on them? Under 20%. So 82% have no authentication on them. So this, in my opinion, is an entire like Redis-like situation where you just have Redis databases on the internet with no authentication with super sensitive data in them. I think you kind of have the same scenario with Zookeeper going on right now on the internet. So, I mean, technically, I didn't release modules for it, but you could get code execution through Zookeeper depending on what its use is, right? So, but at the bare minimum, it's super easy just to pull up a Zookeeper GUI and browse over and view sensitive data. So, that's my last meme. Thanks to these dudes for making Empire, because that's what all the modules are written for. I think you guys saw them talk right before this. And that's it. If you guys want to talk, we're up here. So, thanks.
If you guys have any questions, just come up here to Mike. I got a couple of Docker security books to give away. If you guys could ask a question.
Oh yeah, great. Questions, great. Let's do it.
Yeah, we have like 4 more minutes, and just a quick announcement. 7 p.m. there'll be closing ceremonies in the chill room. So, anyone have a question?
I love that question. Best question. Best question. You rock with a question mark? I don't know.
All right, thanks guys.